Today we'll see about exercise 8.1 in trigonometry, 4th, 5th, 6th and 7th sums. Okay, so the 4th sum is going to be, let's start. What is given is 15 cot A is equals 18. So now we have to find sine A and secant A. This is the given question. Now what is actually cot A? Cot A equals 8 by 15 from the given point, and cot A is nothing but cos A divided by, it is going to be sine A. Nothing but cos is adjacent divided by hypotenuse, the whole divided by, sine is going to be opposite divided by hypotenuse, so it is adjacent divided by opposite is going to be cot A, which equals 8 divided by 15. Now we assume a triangle, right angle triangle ABC, right angle at B, adjacent for A is going to be AB, and that we got it as 8. Opposite for angle A is going to be BC, and we got it as 15. Now we have these three, so by Pythagoras theorem, AB square plus BC square is equals hypotenuse square. So AB square plus BC square equals AC square. Now what we have is AB and BC. We don't have AC. So AC equals root of AB square plus BC square, which equals root of AB is 8 and BC is 15. 8 square plus 15 square, which is equal to 1. This is nothing but 17. So we got all the sides. AC is going to be 17 centimeters, BC is going to be 15 centimeters, and AB is going to be 8 centimeters. Hypotenuse is going to be the largest side, we know that. And from this we can get sine A is nothing but opposite by hypotenuse. So it is going to be 15 divided by 17. And secant A is nothing but 1 by cos. So it is going to be hypotenuse divided by adjacent. So 17 divided by 8. That's it. We got the answers for 4th one. Moving on to the 5th one. Given question is secant theta is nothing but equals 13 by 12, and we have to calculate all the other trigonometric ratios. So now we know secant is 1 by cos, secant theta is equal to 1 by cos theta, which equals hypotenuse divided by adjacent. So hypotenuse divided by adjacent equals 13 divided by 12. Again we have two things, 13 and 12. So 13 square equals 12 square plus, let's assume it is x square. So 169, 13 into 13, 169 minus 12 square is going to be 144, which equals h square. This is 25. So x is going to be 5. We have got the other sides. Let's draw a triangle PQR, right angled at Q. Hypotenuse is going to be 13 and one side is going to be 12 and the other one is going to be 5 from the derivatives got here. With that, moving on to, let's assume this angle. Moving on to sine P will be opposite QR divided by PR. So it is QR opposite divided by PR. Nothing but the hypotenuse. It is going to be 12 by 13. Cos of P is going to be adjacent divided by the hypotenuse. That is nothing but PQ divided by PR, which equals 5 by 13. And then tan P is going to be sine divided by cos, or else we can say it as opposite divided by adjacent. Opposite is going to be QR and adjacent is going to be PQ, which equals 12 by 5. Secant P is going to be 1 by cos, or we can say hypotenuse divided by adjacent. So it is going to be PR, hypotenuse divided by adjacent is going to be PQ, which is nothing but 13 divided by 5. Cosecant is going to be hypotenuse PR divided by the opposite, nothing but QR. So it is 13 divided by 12. And finally, cot P is going to be 1 by tan, or we can say adjacent divided by opposite. This is opposite divided by adjacent. This is going to be adjacent divided by opposite. 5 by 12. So we have derived all the trigonometry. QPA and DCB are two triangles. P and C are going to be right angles. Now we are to prove this angle is equal to this. So angle A is equal to angle B. Should be proved. Now what is given is cos A is going to be equal to cos B. So now what is cos A? Adjacent by hypotenuse is going to be QP divided by QA is equal to opposite by hypotenuse, it's going to be DC divided by DB. Let this be 1. So by Pythagoras theorem, we are going to prove this one and this one square is going to be equal to this and this square, right? AQ equals QP square plus PA square and DB square equals DC square plus CB square. So it's going to be, which equals root of QP plus PA, and this is going to be root of DC plus C and B. This can also be called as a negative value, and if we take this for BC and if we take this for PA, from this PA will be equal to AQ square minus QP square, and from this, because this is the side we are going to prove, CB equals DB square minus DC square. Let this be the second equation. Let's consider this to be the first equation and let this be the second equation. So when we divide BC by AB, then we divide BC divided by AB, what we get is DB square minus DC square divided by root of AQ square minus QP square, which equals, when these two sides are going to be equal, CB can also be equated with this and PA can also be equal to this. So by that, DB square minus DC square, instead of CB, let's substitute it with AQ square minus QP square. So for a constant K, divided by we take the constant k in common, if it's going to be q into pq square minus, aq square minus qp square divided by aq square minus qp square. Cancel. It's going to be constant k. Let this be the third equation. So we have from 1 and 3. From 1 and 3, first equation says qp by qa. qp divided by qa is nothing but adjacent by the hypotenuse equals this side bc divided by db. And now we have got BC divided by AB. This side divided by this side is going to be a constant K. If we substitute it with constant K, QP by QA equals DC by DB also equals BC divided by AB. This is the conclusion we have drawn. And from this, if all the sides are going to be divisible equally, then both the angles has to be in a same range. If we take it, for example, it is going to be 30 degrees. Both the angles are going to be 30 degrees because the sides are the same. Trigonometric ratios deals with ratios and the sides. It is nothing but the relationship between the ratios and the sides. And if the sides are going to be equal, then probably if these sides are going to be equally divisible, opposite is divisible by opposite, adjacent is divisible by adjacent, hypotenuse is divisible by hypotenuse, then it's going to be the same angle. Hence, proved. Coming to the 7th question, what is given is cot theta is going to be 7 by 8. So adjacent by opposite is going to be 7 by 8. In an angle for this theta, adjacent by opposite is going to be 7 by 8. If this has to be 8 and this has to be 7, by Pythagoras theorem, 8 square is going to be 7 square plus, let's assume this to be x square. So this is going to be root 14. Now what they have asked is evaluate 1 plus sine theta into 1 minus sine theta, the whole divided by 1 plus cos theta into 1 minus cos theta. 1 plus sine theta into 1 minus sine theta is going to be 1 square minus sine square theta. 1 square minus sine square theta, and the same 1 square minus cos square theta. This is from an formula x plus y into x minus y is going to be x square minus y square. That is what we have got here. So which is nothing but 1 minus sine square theta that divided by 1 minus cos square theta. Now we have all the three values and we are to evaluate this. We'll just substitute 1 minus opposite by hypotenuse is nothing but root 15 divided by 8 square. divided by 1 minus cos is going to be 7 by 8. 7 by 8 square. So 1 minus root 15 into root 15 will be 15 by 64. 8 into 8, 64. 49 divided by 64. So 64 minus 15 by 64 whole divided by 64 minus 49 divided by 64. 64 we can cancel, and 64 minus 15 is going to be 49, and 64 minus 49 is going to be 15. So this is the evaluation we have got for cot square theta is nothing but adjacent by opposite. So this is going to be 7 by, from this it's going to be 7 by 8. (49) divided by 15. 7 sevens are 49. Root 15 into root 15. Root, it's going to be the square. Square and root will cancel and we'll get 15. So 1 and 2 are same. The first question they gave, and the second one is going to